Okay guys, welcome to lesson 1.5, describing angle pair relationships. Please turn to page 35 of your textbook. I would like you to take a few minutes to define and read page 35 and define complementary, supplementary, adjacent angles right on the first page. Then we're going to jump right into a couple of questions, and the types of questions we're going to be dealing with is something like this. Given that angle 1 is a complement of angle 2 and that the measure of angle 1 is 68 degrees, how would you find the measure of angle 2? Well, complement means that they add together to be 90 degrees, so you're just going to do some arithmetic, 90 minus 68 to get your solution. Super easy. We'll do the same type of a thing with supplementary where it adds to 180. Now if you'll turn the page to page 36. 36 has some additional word problems. I'd like you to look at example 3 on page 36. It looks a lot like this. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. So angle BCE is one angle, and angle ECD is the third angle. Now it says that it's a pair of supplementary angles, so notice that together, using the angle addition postulate, this angle plus this angle equals 180 degrees. So to solve that, we're going to set up an equation. 4x plus 8 is the first angle. When we add it to x plus 2, we get 180 degrees. So in this case, the two supplementary angles were adjacent to each other. That means where the one angle ends at ray CB, the other angle begins at ray CB and continues out. When you have two supplementary angles that are adjacent, we call these a linear pair. So if you can please define a linear pair by looking in your book on page 37. What's special about a linear pair versus just two supplementary angles? Supplementary means they just have to add to 180. A linear pair means that those two angles are adjacent, so that they together make up a straight angle. Okay. Then take a minute right underneath that to define vertical angles. Okay, we're going to finish up real quick by looking at a couple of problems that deal with this. The first one is if you look at a diagram like this, can you identify all of the linear pairs? So there's lots of different choices, but we could say that angle 2 right here and angles 3 and 5, that those together make up a linear pair because they make up a straight angle. We could say that angle 1 and angle 4 is a linear pair. Angle 4 and 5 is a linear pair. So any pairs of angles that make up a straight angle is a linear pair. Now when we talk about vertical angles, we're looking at when two lines intersect, angles that are opposite of each other. So if you focus in on this line, and this line intersecting, do you see that angle 1 and angle 5 share the same vertice and they're opposite of each other? Those would be considered vertical angles, and vertical angles are always equal. If you see a problem like this, if it tells us that two angles form a linear pair, and one angle is 5 times the measure of the other. Notice that you define one of them as x and the second one as 5 times that, because that was the given information in the problem. So how would you set this up? Given the fact that it's a linear pair, these two things are supplementary, so they add to 180 and you solve from there. Pretty straightforward. Okay, that is all you need to worry about from this lesson. I would like you to take a minute, because we're going to start class tomorrow with the reading on page 38. So if you look at the top of page 38 in your textbook, we're going to do an activity to start class on Friday where I'm going to give you some information and I want you to tell me all the things that you can conclude from a diagram. And what we're going to really want to pay attention to in geometry is that you can't look at an angle and say that it's 90 degrees because it looks 90 degrees. You can only conclude from a diagram things that are marked or measured. So if you look at this example, there are some things you can conclude from the diagram and some you cannot. For example, here are some things that you can conclude. All points shown are coplanar. So you can conclude that these all lie on the same plane. You can conclude that A, B, and C are collinear. They're all on a line. And that B is between A and C. You can conclude that line AC, ray BD, and ray BE all intersect at point B. You can also conclude that DBE and EBC are adjacent angles, and that the whole thing, angle ABC, makes up a straight angle. Here are some things marked that appear to be true, but are false conclusions. Even though ABD looks to be like it's a right angle, you cannot conclude that unless it's marked. And even though B appears to be between A and C, we cannot conclude that it's a midpoint. So we're going to do a little bit of work on that, and it's something that, especially on the ACT test, people will try to trick you all the time by drawing something that appears to be equal or congruent, and they're not. So the big thing is that you cannot conclude anything that's not specifically marked or measured. So please don't say angle 1 equals angle 2 because they look like they're the same. That's not the case. Okay? All right. Thank you. Have a good night, and see you tomorrow.